Welcome to this Prolon training video. My name is Daniel Kerwin, and in this segment I'm going to give an overview of Prolon Controls. We'll review the types of buildings where Prolon is typically installed, the contractors who typically install Prolon, and the different types of equipment Prolon can control. This overview will be split into two parts. The first part will be a PowerPoint presentation, and the second part will be a software demonstration to give everyone a good idea of how our system can be configured. Okay, so let's get this started. I usually like to show this picture, which shows a commercial neighborhood which can be found in any city or town. And I usually like to show this picture just to show the amount of opportunities we can find with Prolon Controls. Every single green circle which we see popping up here is a potential Prolon system. And as we can see, it goes as far as the eye can see into the skyline. Every single one of these could be a potential Prolon project. So what is Prolon Controls? We are a controls manufacturer, and we make controllers which are designed for the small to mid-sized commercial building market. Our goal is to create a building automation system which is very simple to configure and operate and is very affordable, as much for the installing contractor as for the end user as well. What types of buildings can we typically find Prolon? Generally, Prolon projects will range between the 50,000 to 100,000 square feet or smaller. So we're talking about office spaces, schools, medical clinics, whether it's a dental clinic or any other health clinic, retail stores, car dealerships, churches. Generally we're looking at buildings which can be 2 or 3 stories high, maybe up to 4 stories. So we will not find Prolon in a hospital, or we will not find it in a high-rise building. Prolon fits very well with those smaller commercial projects. Who is Prolon available to? We market our system to mechanical contractors, service contractors, and controls contractors. Essentially, most contractors involved with HVAC. On the mechanical and service side, we have witnessed many companies who have been wishing to get more into the controls market, but have been unable to do so for a variety of reasons. Whether it's because the complexity of a building automation system was too high, or they didn't want to pay registration and annual licensing fees, or maybe they simply couldn't financially justify having a dedicated controls technician on staff. All these are reasons of why these mechanical and service companies may have been a little bit shy to get into the controls market. But now with Prolon Controls, we are able to offer them a full control solution, which they can then in turn offer to their customers, and they don't have to worry about having a controls technician on staff full-time. Prolon can also be an attractive option for controls contractors. We do not intend to replace their existing line of DDC controls with Prolon, but simply show them that Prolon is a perfect solution for their smaller projects. Often a controls contractor will not be able to install a full DDC system in a small building due to the high price of their system, especially when you look at the combined costs of hardware and the extensive programming hours needed to set up the controllers. Controls contractors will usually see Prolon as another tool in their toolbox and will see a fit for it in smaller buildings when their full-blown DDC line may be a tad too expensive for the project's budget. And as we can see here on the bottom left, automation programming is not required. So as soon as someone is a little bit computer savvy, they should have no problem whatsoever navigating through our software. What applications or type of equipment can Prolon's devices control? Let's start with the zoning systems. Prolon has dedicated controllers for rooftop units and VAV zones. Whether the system is true VAV or VVT, Prolon's devices are able to control both. We have developed controllers for other types of equipment typically found in light commercial buildings, such as controllers for boilers, heat pumps, cooling towers, makeup air units, and so on. Now in the following slides, we're going to take a look at each one individually. Before I start on the VAV controller, something important to point out is that all Prolon controllers can be standalone or networked. This is a great feature because it gives contractors the option to install standalone controllers first, and if they wish to network them later on, they may choose to do so. This can be particularly useful for a retrofit project, where the customer may not be willing to replace the entire control system on day one, and would rather replace the existing controls one sector at a time as their budget allows. In this case, Prolon's controllers can be installed one at a time and would operate standalone until the day where the customer would want them to be networked, in which case we simply have to connect them together using a 2-conductor cable. Okay, on to the VC2000. Like I mentioned, it can be standalone or networked. The controller uses a Belimo actuator, hence the orange color of the controller. The VC2000 uses their Halamo technology. It uses a brushless DC motor with integrated position feedback, and it periodically resynchronizes its open and closed positions. For wall modules, Prolon offers 3 different wall sensors, which we can see on the top right here. First we have the T200, which has an adjustment knob and no display. Next we have the T500, which has an adjustment knob and a digital display. And finally we have the T1000, which has a touchpad and a digital display. Now the T1000 is more than a simple wall sensor. You can access its digital menu and change any parameters on the VC2000 controller. So whether it be for configuring the outputs, the damper, flow settings, everything on the VAV controller can be configured from the T1000 wall sensor. The VC2000 is available in 2 models, pressure dependent and pressure independent. The pressure dependent model does not have an airflow sensor, while the pressure independent model has an airflow sensor for accurate airflow control. The VC2000 controller also has 1 digital output and 1 analog output, which can be used for any reheat, whether it's electric or hot water, modulating or staged. The outputs can also be set up for fan-powered boxes, baseboards, or zone valves. You can also connect a slab temperature sensor and control the slab temperature for radiant floor applications. Prolon offers a configurable thermostat, the T1100. It has 1 digital output and 1 analog output, and each output can be used for either heating or cooling purposes. So it could be configured as a 1 heat, 1 cool thermostat, 2 heat, or 2 cool. This device is useful for controlling equipment such as zone valves, unit heaters, and exhaust fans. The thermostat can also be used to control radiant flora applications. We also offer another VAV controller, the C1000 VAV. You will notice that this controller does not have an integrated actuator. It is usually used in retrofit applications where the contractor wants to reuse existing actuators, whether they are floating or modulating. Since it has 4 digital outputs and 1 analog output, it is able to control an external actuator and still have additional outputs for reheat, fan-powered boxes, and so on. On to the M2000 series controller, which is Prolon's flagship controller. It is designed to control most types of air handling units, such as rooftop units, heat pumps, fan coils, air handlers, and so on. Essentially anything with a fan, heating coils, cooling coils, maybe static pressure control, maybe economizer control, and so on. We have developed what we call an obsolescence-free design for all our controllers. We mean obsolescence-free because Prolon regularly releases updates, about once or twice a year, and all updates are retrocompatible with existing controllers. These updates are completely free of charge and can be downloaded from our website. Prolon's updates always add additional features. They never take any existing sequence away. So if you have any controllers which were installed, say, 6 or 7 years ago, you could update them free of charge and get all the latest features and sequences. The M2000 has 9 inputs and 8 outputs, 5 of which are digital and 3 of which are analog outputs. All outputs have handoff auto switches to help contractors with troubleshooting if they wish to manually override some outputs. The controller also has an internal time clock with scheduling and holiday calendar. Prolon also offers the M2000 controller in a pre-wired UL certified panel. All the inputs and outputs are pre-wired into the terminal strip at the top. It comes with 5 isolation relays and a fuse. Everything is properly grounded and the panel comes with a wiring diagram. Prolon stocks these panels, so if you need multiple panels on short notice, Prolon can easily provide them. Prolon's rooftop controllers are best suited for units up to 25 tons, such as we would see in most light commercial buildings. We can control units up to 50 or 60 tons. However, sometimes an additional controller is needed to be able to monitor and control all components. For the cooling, the M2000 can control up to 4 stages of cooling. In most units smaller than 25 tons, 2 stages is the standard. But for those larger units, we can control up to 4 stages. The M2000 can also control modulated cooling if we wish to control a chilled water valve. There is a dedicated output for economizer for free cooling. For heating, it has 2 digital outputs and 1 analog output. So whether the heating is staged or modulated, electric, hot water, or gas, Prolon's controller can take care of it. There is a dedicated input for a static pressure transducer, so we can control either a bypass damper or a variable frequency drive in the case of a zoning system. The M2000 can control an exhaust fan based on occupancy or a power exhaust if the unit has one. Prolon's system always monitors the supply, return, and outside air temperatures, and we can apply low and high limits to cut out the heating or cooling if those temperatures get too high or too low. Prolon has a humidity controller, the C1000HU. This device can control humidifiers, whether they are on-off or modulating. The controller has an outside reset scale and high limit. The controller can also be used for dehumidification purposes. Prolon offers a robust boiler controller, which can control up to 4 boiler stages and 2 pumps. The boiler stages and pumps each have lead lag and equal runtime sequences, as well as a failover sequence for redundancy purposes. So in case a pump fails, the backup pump will turn on. This device can also control up to 2 modulating boilers. This controller has an outdoor reset in case we wish to have the hot water set point change depending on the outside air temperature. Other included features are warm weather shutdown and timers on the outputs to monitor how long each piece of equipment has been running. Prolon also offers a makeup air unit controller. Whether the makeup air unit comes with factory controls or has no controls whatsoever, our controller can be a perfect fit. It can control the heating and cooling of the unit, the outside air damper, exhaust fans, and the supply fan. It can be configured to modulate the supply fan's variable frequency drive to maintain building pressure. Here is a nice little combo application. If you have a building which has a water loop, and this water loop is supplying multiple heat pumps, Prolon can control the water loop and every heat pump as well. We have a dedicated water loop controller which can operate a simple cooling tower with a boiler. Prolon's heat pump controller can control either water-sourced or air-sourced heat pumps with optional supplemental heating strip. Finally, we have the Flex.io, which is a little bit different from the other controllers in that it is not application specific. All the other controllers we have reviewed up until now had dedicated applications, and so all inputs and outputs were pre-configured for that application. The Flex.io is different in that you can configure it to control a variety of side loops. The inputs can be configured to read temperature, pressure, gas levels, humidity levels, or can be a simple dry contact for status. Each input can then be linked to an output, and we can configure the set point and other parameters to determine when does the output turn on and off. The controller has both digital and analog outputs, so it can be simply used for on-off operation, or you can modulate a signal. It is ideal for monitoring temperatures. We can control variable frequency drives for pumps and exhaust fans. We can control valves, look at the status of any piece of equipment, and so on. Each output can be assigned automatic overrides based on occupancy or based on outside air temperature. Another feature is that the controller can receive multiple schedules, and we can assign each schedule to a different output. This allows us to activate different outputs based on different schedules. People may use this function for lighting control, or perhaps to control multiple exhaust fans based on different schedules. Okay, so that wraps it up for the controller overview. In terms of architecture, a project can start off with simple standalone controllers being installed one at a time. If the customer would like a networked system, at this point we can simply connect all the controllers together in a daisy chain using a 2-conductor cable. We can have up to 127 controllers on a single network. When we add the network controller, now we can access our system remotely via the internet. Now, it's not about having one rooftop with 100 zones. No, we could set up 10 rooftops, and each of those units could have 10 zones. That would be 10 rooftops and 100 zones, which brings our total up to 110 devices. We'd still have room for another 17 controllers on that network. There is no limit on the types of controllers on any given network. So you can mix and match all our different controllers as long as we are within the 127 device limit. For example, you could have 3 zoning systems with a total of 50 zones under 3 separate rooftop units with a boiler controller and 2 Flex.io controllers for side loops. Or in another case, we could have 80 water-sourced heat pumps with a water loop controller. The possibilities are endless. Okay, on to our last controller, the NC2000 network controller. As I mentioned before, this device is necessary for any kind of remote connection. It can also act as a central scheduling device. We can configure up to 16 separate schedules and redistribute them to any controller on the network. This makes it easier for any kind of schedule change. Instead of changing it in each individual device, we can centralize it through the network controller. Another feature in this device are the email alerts. These alerts can be set up to monitor any point on the system, whether it be temperature, pressure, an output, a status, and so on. Anything that can be read on our system. We can send each alert to up to 3 separate email addresses, and it can monitor up to 100 alert conditions. There is also an outdoor air temperature sharing function, in that a single outside air temperature reading can be shared across the network to all devices. So you can use a single outside air temperature sensor for all your networked devices. Last but not least is the trending feature. We can configure this controller to log any variable on the system, and we choose how often does it log that variable, whether it be every 30 seconds, every minute, every 5 or 10 minutes, whatever works best for the contractor. All this information is stored on an SD card, which can be inserted in the NC2000, so we are not using any internal memory of the controller for this log. Since we are using an external SD card to store all the information, it can record and hold the data from several weeks, months, or even years worth of operation. How can we configure these controllers? The Prolon offers a configuration software called Prolon Focus. It is a free software, no annual license fees or registration fees required. Simply go to Prolon's website and download it for free. What's particular about Prolon Focus is that the graphics will automatically change based on the chosen sequence, so we don't have to worry about configuring the controllers and then making the graphics match the program. No. With Focus, any change in the configuration and the graphics will automatically follow to reflect that change. We also offer mobile applications for both Android and Apple devices, which are available on both app stores. You can connect using these mobile devices either over an internet connection or by using a Bluetooth connection. So here on the screen we have a screenshot of what the graphics of a zoning rooftop would look like. And the other screenshot we have are the graphics for a VAV controller. On this slide here, we have another view of our system. Each icon represents a different rooftop unit, and we can immediately notice the different colors. The first icon is blue, so that rooftop is cooling. The second rooftop is red, so it is heating. And the third rooftop is green, so it is simply ventilating. And so to conclude this presentation, with Prolon you will find that it is an extremely reliable control system and very simple to install and configure. Overall, it is less expensive to purchase and install a Prolon system, especially when you consider how little time is required to configure the controllers. Prolon system first priority is always to provide comfort to all of the occupants while maximizing the energy savings at the same time. And you will see that our system is always evolving. We're always coming out with updates, trying to improve what's already there, and we always make sure that all these updates are retrocompatible. So that concludes our PowerPoint segment. Now we are going to take a look at the Focus software, and we will have a little demonstration. To open this Focus software, simply double click on the icon right here which says Prolon Focus. It's going to ask you to log in, so I'm simply going to put my password right here. If you wish to create your own account, you may do so simply by clicking on the new account button and by filling out all the information. Or if you don't want to do any of that and you just want to access the software without creating any kind of profile, simply click on the continue as guest. And I'm going to create a new project. Okay, so here is our working space of our software. On the left hand side we can see all the different controller icons. So we have divided it into 3 different sections. So first we have the master controllers. So for the zoning rooftop, zoning heat pump, hydronics. So this one would be for the geothermal heat pumps or for a makeup air controller right there. The next segment is the zone controllers. So we have the zone controllers for VAVs, the thermostats, and the single zone rooftop or single zone heat pump. And the third segment, we have the other controllers, which would be the humidity controller, the boiler controller, the water loop, the copper theft, and the FlexIO controller. In this case, I'm going to be connecting onto our office, and we're going to be doing it through an IP connection. So to set up the IP connection first, I'm going to go on Project, Edit, and I'm going to click on the connection tab right here. And I'm going to change the connection type from serial to TCP/IP. And in this case, I'm going through our internal network, so our internal IP. And the IP address of the network controller is 192.168.214.99. Click on Save. Okay. So if I want to actually connect onto the controller, I have to press on the Connect button. So when I do that, I have a little green check mark which confirms that I am currently connected onto the controller. So on our system here, I know that we have a rooftop, so I'm simply going to go on to the master controller segment, and I know we have a rooftop, so I'm just going to drag and drop it into our space here, and it's going to ask me for an address. So I know that this rooftop has an address number 10. Put number 10, and it pops up. Already we have a bit of information pop up. We can see what the temperature in the supply is, what the return temp, and the outside air temperature. Now, I also have some VAV zones which I would like to add. So I could simply click on the zone segment and drag and drop a zone controller like this. And so if my zone controllers have already been addressed, well then I could add them one by one in this way. However, we have a quicker way and more efficient way of doing this. If I simply right click on the rooftop controller, we go to Get List. If I click on this, it's going to put a call out to the network, and all the zones who hear the call will answer back. And there we go. So here I have 5 zones which just popped up. Each zone, we can see the information. So we can see what the space temperature is, what the set points are, what is the demand of that zone, and what is the damper position or the actual flow. Now we can notice that the icons have different colors. So if a zone is blue, it means it's calling for cooling. If the zone is red, it means it's calling for heat. And if the zone is green, it simply means that the zone is satisfied. Now these colors also apply to the rooftop as well. So if the rooftop is blue, it means it's actually cooling. If it's red, it is heating. And if it's green, it is simply ventilating. So let's say I want to configure one of these controllers. Well, I could simply double click on it. And there we go. So these are the default graphics for a brand new controller. So if you get a VAV controller and you take it out of the box and you connect your computer into it for the first time, this is exactly what you're going to see. So we can see what the damper position is. We can see the temperature in the supply. We can see the state of our 2 outputs, so of our digital and our analog output. And we can see the space temperature with our heating and cooling set points. Let's say we would like to configure one of these elements. Let's say I would like to configure my damper right here. So I can just hover over it and double click on the damper. It brings me to the damper configuration page. This is as complicated as it's going to get when configuring a ProLon controller. It's configuration pages. So there's no programming involved, whether it's box programming or line programming. Everything is done within these configuration menus. And another feature is that when you receive the controller, well, these menus are not going to be blank. So all the menus are already filled out. So the contractor simply has to tweak some of these values. So he doesn't have to go through each menu changing every line because everything is blank. No, when he gets it, it's already pre-configured, and he just has to tweak maybe 4 or 5 values to get it to work exactly how he wants to. So we have boxes with values in them, we have drop-down lists, and checkboxes. So just going through a few of these parameters, well, we have our minimum damper opening position, our maximum damper opening position, we have our damper opening direction, so we don't have to make that change on the controller, so we can do it through the software right here. If ever there's a parameter that people aren't sure what it means, or they're not sure how it's going to impact the sequence of the controller, you can always just hover over each line, and there's a little yellow pop-up, which is essentially going to explain what does that value mean and how is it going to influence the system. So this is going to help you to understand how the controller works instead of always having to go back to the software guides. And as we can see, all the different ones have different explanations, and sometimes we'll even have some with some diagrams which will help explain the concept a little bit better. Okay, now let's say I would like to configure something else. Let's say that this zone has a duct heater, and let's say it's a modulating duct heater. So I can simply go onto the analog output, double click. At the bottom here we have special function, so I'll put special function duct heater. We can choose what the voltage is, it a 0 to 10 or a 2 to 10 volt range. I can press on the apply button, and when I go back to the home page, we can see that the duct heater has just appeared. So the graphics will automatically adapt to your chosen sequence. Let's say I would like to add something else. Suppose we have a project where it's a fan powered VAV, so now I would like to control a fan with my digital output. So I could double click on the digital output, go to special function. Here we have fan powered box series or parallel, so it depends which configuration. So let's choose the parallel configuration, press on apply, and now we have the fan graphic which has just popped up. If you right click on an element, you can override it from here. So I could say override my damper to 50%. I could override my duct heater to 100%, and I could override my fan as well and turn it on. So we can see that every element which has been overridden is currently flashing in yellow, and they can also see the two outputs here are also flashing as well. If ever somebody does an override and they forget to remove it and then they try to leave, so they try to exit the controller, we do have a little warning pop-up which is going to appear so that people can't accidentally forget that they had put an override. Or I could simply click on resume normal, and that's going to remove all overrides from this controller. And also here on these outputs right here, I can right click on it and I can rename it. So I could rename the digital output fan right here, and the analog output was for the duct heater. And there we go. Alright, what else do we have? I could do config temperature. So I'm not going to go through every single box in this menu, but what I do want to show is the set point limits, so we can lock the set points in within certain limits. We have unoccupied mode as well, so this is for nighttime setback for energy savings. The VAV controller has an analog input which can be used for different purposes. So I could go on config other right here, and here we can choose what is that input going to do. So one thing that we could look at is the discharge temperature. So in this case we would be monitoring the discharge temperature after our duct heater. We can use that input for other functions as well. We can do it to monitor CO2 levels. So now we'll know how much CO2 is in the space. Another feature on the Prolon Focus software is our template system. So in the case where someone may have a project with multiple VAV controllers, we can simply connect and configure one VAV controller, and then we can save its configuration as a template and then reapply that template to all the other controllers. That way they will all be configured in exactly the same manner. So we're going to be saving a lot of configuration time by doing this. What we've been seeing here is a pressure dependent VAV controller. So this type of VAV controller does not have a flow sensor on it. If we did want to look at a pressure independent model, so where we are actually measuring the actual flow into the space, I can just go take a look at the one which I have right here. And so right here we can see our flow sensor. If I double click on it, here we have our minimum CFMs, maximum CFMs, and the reheat CFM. So essentially when the duct heater turns on, we have a new minimum flow on the VAV controller. And here we have our duct setup where people can put the duct diameter and the K factor for balancing purposes. We can see here that two names have popped up on these two icons. And that is because every time that we would open up the controller, then it would retrieve the controller's name. So we are able to give a name to every controller, and they're always going to remember their own names. So I can always just go retrieve those names just by right clicking in the blue space and click on Get Names. And here we go. So here we have all of the names of the controllers which we had previously named when these controllers were installed. Okay, so now we're going to take a look at the Rooftop controller. So I will just double click on the Rooftop icon here. Okay, so here we get the visuals of what the default configuration of a Rooftop controller. So once again, once you get a Rooftop controller, you take it out of the box, you power it up, and you connect to it for the first time, this is exactly what you're going to see. So we can see the cooling stages, we can see the fan, the heating stages, we can see the temperature in the supply, the return, and the outside air as well. Additionally, we can also look at the bypass for static pressure control and the economizer as well. If we wanted to configure any of these elements, we do just like we did before. So if I want to take a look at the cooling stages, I can just go to the cooling stages and double click on it, and it'll bring us to the configuration menu. So here we can choose how many cooling stages do we have, when do those cooling stages turn on and turn off. So we can play with the on-off points right there. And we also have minimum on time, minimum off time, as well as interstage activation and deactivation delays to avoid short cycling. If we take a quick glimpse at what the fan configuration looks like, once again just double click. Usually just looking at this menu can be quite self-explanatory, so it can be very easy to configure it so that the fan will operate in the manner that we want it to. And just to take a look at a third aspect, which would be the heating. This menu looks a little bit different from the cooling aspect, but it's just to give you an idea of the configurability of this controller. The way it's currently configured, it is to control the static pressure using a bypass damper. But what if we don't have a bypass damper? What if instead we have a variable frequency drive? Well, we would like to change that. So we can simply go to Config, Edit Display, do Pressure Control Mode, change it to the variable frequency drive, press on Apply, and here we can see that the graphic of the variable frequency drive has just appeared. So once again, just to show how the graphics will automatically adapt to any change in the configuration. Okay, now we'll just take a quick look at scheduling. I'll do network, schedule. So here we can put our weekly routines. So I could say on Monday, the unit will become occupied at, say, 6 a.m. And as we can see here, we have 4 on-off periods for any given day. So I can just go into the following off section here. So essentially when the unit is going to become unoccupied, so I'll put 8 p.m. and then I can say I want to take my Monday schedule and paste it to the other days of the week, and I just did my weekly schedule. We also have a dedicated schedule for holidays. Now, which day of the year is a holiday? Well, we can simply do network calendar, and here's our holiday calendar. So here we can choose which days of the year is a holiday. So that way on those specific days it will be following the holiday calendar and not the usual weekly calendar. Alright, so here's a nice view of our zoning system. We are also able to put background pictures. I can select a new background. So any JPEG, PNG, or GIF image. So I have one right here. I will click on open. It takes a moment to load up. So it's going to take your picture and it's going to put it in the background. So for any kind of floor plan which you may have, as long as it's in a picture format, it will not accept PDFs or AutoCAD formats. So any kind of picture format. And then I can go back onto that option and I can resize my background. I can make it small, I can make it large. So here's a pretty good size. And then I just have to move my icons around. Maybe bring my rooftop down there. And so here we have a nice view of our system. And we can see which zones or which icons are in which office. We're also able to minimize the size of each icon. All we have to do is click on the address right here, and it's going to make it smaller. So click it once, as such. If somebody wanted to, they could then move these icons as to where the actual thermostat is in that specific space. And we can notice that all the icons still retain their green, blue, and red outline. So we still have a visual indication if the zone is calling for heat or calling for cooling. Okay. Hey, the next controller I want to show is our boiler controller. We do not have one currently on the system which I am on right now, so I'm just going to disconnect. All of the icons are going to go gray, and now I'm simply going to bring in a offline boiler. So I'll just go here and I'll drag and drop, say, my boiler controller, and I'll give it address 50. Okay, so if I double click on the boiler, so here are the graphics, or the default graphics of our boiler. So we can see we have 2 pumps and our boiler right here. We're monitoring the temperature in the supply and the return, as well as the outside air temperature. Now, if I double click on the boiler, we can choose how many boilers there are, as well as how many stages. So we could have 1 boiler with up to 4 stages. We could have 2 boilers with up to 2 stages each. So if I press on apply, here I have our 2 boilers. We could have 3 single staged boilers right there, or 4 single stage boilers. So the boiler controller has 4 digital outputs so we can do any combination of up to 4. Obviously here we have the minimum on time and minimum off time to prevent short cycling, and we also have a lead lag system on our boilers, so in case one boiler fails, well, the other ones are going to turn on. If we take a look at the pumps, so here we can choose how many pumps do we have. Is it 1 or 2 pumps? So if we just have 1 pump, then the graphic will automatically change. If we do have 2, well, we have 2 general sequences. If ever it's a main pump with a backup pump, then we'll see it as we saw before. Or in case it's in case we have pumps on a primary loop and a secondary loop, well, as we can see, the graphics will change a little bit. We can activate our pumps based on outside air temperature or based on a heating call. So when we activate it on outside air temperature, that's basically your freeze protection right there. Or we could turn it on when there is a boiler call. If I just put the pump sequence back to the original configuration, so that way we would have a lead pump and a lag pump, well, the pumps also have a lead lag sequence, so we can alternate pumps after each call. We can alternate pumps with a fixed runtime, which we're able to input right here, or we can use the equal runtime feature. And the pumps also have minimum on time and minimum off times. We have also a pump exercise sequence, and I find that this sentence speaks for itself. Exercise pumps after every 48 hours of inactivity for 15 minutes. So this will make sure that your pumps don't turn off for too long of a period. All right. Now this controller, like I had mentioned before, this controller is able to be completely standalone. So if we want this boiler controller in a larger network, we're able to do that. If we are simply looking just for a boiler controller and nothing else, this controller can do the job just fine. The last controller we're going to look at is the network controller. So to access that one, we're simply going to go on to the global button right here, and we will drag and drop a network controller and put its address, which its default address is number 99. The network controller is necessary if we want any kind of remote access connectivity. So if you would like to access your Prolon system through the internet, we absolutely need a network controller. It also has other features such as email alerts and trending as well. So let's take a quick look at those features. If I want to configure it, just double click it, and I could go config alerts. Alright, so here's the menu where we configure the email alerts. So I can simply click on add. Here we'll have a list of all the controllers in our system. So I could say, let's take a look at Rooftop number 10. Then we have the source here. So we can double click on this and we'll have a drop down list of all of the points of the controller. So all the inputs and outputs are here. And so we can choose any of these points which we want to monitor. So let's say we want to look at the supply temperature. We can set the condition, so whether it gets smaller or larger than. So I could say if the supply temperature gets colder than 42 degrees for a certain delay, so the default delay is 2 minutes. So if the supply temperature is colder than 42 degrees for 2 minutes, then we can send off an email alert up to 3 different addresses. We are also able to combine multiple conditions into a single alert. So I could simply click on add. Let's say we want to look at the rooftop again. And in this time, I want to tie this alert with an occupancy state. So I could say I want to look at this condition when it's occupied, and to bind them together we have to group them right here. So I could say I could put both of these conditions in group 1. So what that does is that the email will only be sent off once all conditions of group 1 have come to pass. So in this example, the email will only be sent if the unit is occupied and the supply temperature gets colder than 42 degrees. If ever the unit is unoccupied, so during nighttime, then we would not get that email alert. So what this allows us to do is not simply be alerted due to a specific point, but really looking at that point in a context as well. We can put up to 100 lines here. So we could technically have up to 100 separate email alerts, or if we start grouping them together, well then we would not be able to reach that 100 limit. So it really depends how many controllers and how many points are we trying to monitor and be alerted. So we can put up to 100 lines in this alert configuration page. Next I want to show is the trending feature, and this is going to be the last feature which we're going to cover. So this menu right here looks very similar to the email alert menu. So if I want to add a trend or a data log, so once again I can choose which controller. So I could say in this case I want to look at VAV number 11, which is the entrance. I can double click on the source. So here we have a list of all of the points of that controller. So in this case I would want to log the zone temperature, and I can choose what is the interval. So it can either be, well, in this case we have 5 seconds, but we probably don't want 5 seconds. That might be a bit too fast, so I could put it to 1 minute. So now every minute it's going to log the space temperature. I could add on the rooftop controller as well, and if I wanted to, once again, we can choose which point we want to monitor, and maybe I want to monitor the supply temperature every 45 seconds or every 2 minutes, whatever we want it to be. All this information is stored on an SD card, which can be inserted onto the network controller. So it doesn't matter whether you have a 1 gigabyte SD card or a 2 gigabyte or a 4 gigabyte SD card. With all that space, you will have more than enough room to have a data log which could go on for months or even years, depending on the amount of logs and the intervals which we choose to put. If we want to monitor, well, if we want to take a look at the trends, I can simply go on Open Graphing Utility right here. When I click there, Excel opens automatically, and it's going to prompt you to import your data log file. So I'm simply going to go here. I have a sample one right here. So here I have a 36-hour log. I will import it. And there we go. So what this Excel file does is that once it opens the data log file, it's going to configure everything so that we can see it in a graph. I'm just going to zoom in a little bit here. So we can compare any two variables at the same time. So in this case, I'm looking at the supply temperature and the cooling stage 1. I'm just going to move up in time here. So here we have our timestamp at the bottom, so we can move the time up. There we go. So I have the cooling stage on the right hand side, and here we have the red line. So whatever is red is the cooling stage, and I can see that it changes between 0 and 1. So it's either on or it's off. And then on the left hand side is the supply temperature, and on the left we have this blue line. So whatever is blue on this graph is going to be the supply temperature. Suppose I would like to take a look at 2 other points. Let's say I'll choose my static pressure in the duct system, and I'll go compare it with the bypass damper position. First thing we'll notice is that the units on both sides have changed to adapt to the point which we are looking at. So in this case, on the right hand side, it's the bypass damper position, so it's in a percentage, and for the static pressure, it's in inches of water here. If I want to zoom in a little bit, because our timestamp is pretty large, on the left hand side here it's 5:50 a.m. and this line here is about almost 10:40 a.m. so this is almost our entire morning. So if I just want to take a closer look at it, I can zoom in, and there we go. So now we can look at the duct static pressure versus the bypass damper position. All right. And that concludes our video segment for today. You can find more information on our website at www.proloncontrols.com.